In this video, we're going to explore risk. In this case, we're going to look at individual assets, and then we'll combine some assets into some portfolios. But what we're looking for here are the statistics themselves. So let's think about three assets, A, B, and C. And I've already input the rates of return that we expect to get for these particular assets in certain economic conditions. So in a really good economy, we expect to get about a 20% return from asset A. We expect to get 10% in an average economy, and in a bad economy, we would expect to get a negative 5% rate of return. So these are expected returns, and we'll talk about how we can calculate this in later videos. The other important aspect, though, is we have to incorporate probabilities. What's the chance that we're going to have a good economy in the future? Now, this adds even more uncertainty to the numbers that we calculate. But maybe what we'll do is send out a survey, ask some economists what they think about the possibility of the economy moving forward. Maybe we ask them to predict GDP or GDP growth, and then use some kind of a frequency distribution to come up with these percentages. But I've come up with, again, 15% chance of good, 45% of average, and a 40% chance of a bad economy. Notice that they add up to 1. So when we incorporate probabilities in the returns, now we can look at the statistics. The expected return is the average. For asset A, 5.5, asset B, 1.4, asset C is 8.1. So asset C obviously has the highest rate of return. To measure risk, we want to use standard deviation. And you notice here standard deviation, if you calculate across, 9.2 for A, 9.6 for B, and 8.2 for C. So C not only has the highest rate of return, but it also has the highest risk level when you talk about standard deviation. Now, the challenge with making these comparisons on standard deviation is that those numbers are influenced by the size of the numbers. So if you look at this standard deviation number, if we just multiply each one of these numbers by 100, right? So negative 1,000, 800, 1,500. You see the returns, the variance, these things all change, but the coefficient of variation doesn't. So the coefficient of variation allows us to modify the returns based on, so it kind of gives us a standardized level of risk. So in this case, again, you can still see that standard deviation, which is the amount of risk for every 1% of return, is still the lowest. Now, the thing that we can do, we can look at a couple other statistics. Let's look at correlation. How are these assets related? A and B are positively related. It's a pretty high correlation, 0.996. But A, C, and BC are negative related. Again, a pretty high negative correlation. So what will happen when we combine these assets? So if we add in this portfolio weights here, let's say we put 30% of our money in A and we put 70% of our money in B. Now they are very highly positively correlated. So when you look at the risk really doesn't change all that much. It's in between the two because they are positively correlated. Now, the average return you're going to get 30% of 5.5 and 70% of 1.4. So again, this calculates the statistics for us. But what if we put, instead of 30% in A, what if we put, 30% in A, and let's put nothing in B. Everything else then will be in asset C. So we have 30% in A, 70% in C. Now let's see what happens. Again, a lot more return because there's more weight to the higher asset return. But look what happened to risk, right? Not only did the standard deviation fall, which hopefully we would expect to see, but when you standardize that, right, it is half the risk of what the least risky asset is in the portfolio. So what this is showing us is diversification at work. When you combine assets that have negative correlations, you will get more diversification than if the assets are very highly correlated. So again, the important information from here is about the risk of these individual assets and then what happens when we create portfolios. Some other statistics here. Range is just the highest minus the lowest, right? So 20 minus a -5, that's 25%. Not a great statistic, but again, it does have an indication of some risk level. Now, the bottom two rows here are the 95% confidence level. So what this implies is that next year's returns, there's a 95% chance that it will be between -12 and 23. Again, if you look down here to the end, right, -8 and 24, right, there's less distance here than there is here. Again, that's an implication, again, of lower risk. And if you look at the portfolio, right, it's there's a 95% chance that this portfolio will be greater than zero. In fact, more than 95% chance that if we create this portfolio, right, there's a 95% chance that it's going to be between 0.5% and 14%. So again, another way of just analyzing and looking at risk. See you in the next video.